All right, so this is section 7.1. We're going to start off with angles in general. So first of all, what is an angle? Well, in order to find an angle, we're going to have to start with, back up a little bit to what a ray is. So some geometry. A ray is basically just an endpoint and a line segment that extends infinitely in one direction. So like that's a ray, that's a ray, that's a ray. Now if you put two rays together and they share that endpoint, they form an angle, right? So you can see there's one ray here, one ray here. They share that endpoint. That's called the vertex of the angle. And then this opening right here is our angle. Okay? So an angle is said to be in standard form or standard position if the vertex is on the origin, 0, 0, and the initial side, that's this bottom part right here, is along the positive x-axis. This part up here, this ray, is called the terminal side. Now, its location varies. It might be in quadrant 1, it might be like right there on that y-axis, it might be in quadrant 2. You just don't know. That's what's going to change. But the initial side is going to be fixed, the vertex is going to be fixed. So that's what we're going to call the standard form or standard position of an angle. Now, you probably already know this, but the quadrants are labeled, 1, 2, 3, 4, so they're labeled in this counterclockwise direction. Now, the angle measures that we talk about, if we start right here, remember how we said that that was going to be our initial side, so that's where we're starting from, initial meaning start. That's going to be our 0 degree mark. Up here, the measure from here to here is a right angle. So that's a 90 degree angle. So each one of these quadrants is a right angle. So each one of these quadrants measures 90 degrees. So we get that starting here, we're at 0. Up here, that's 90 degrees from this initial side. From the initial over to here is 180. And you can just see how these go in 90 degree increments. So that one trip all the way around is 360 degrees. Now let's talk about the names of some angles. Again, you may have seen this stuff before. This may be a review. If it is, awesome. An angle that measures between 0 and 90 is an acute angle. Now that 0 and 90 is non-inclusive. That does not include 90 degrees. It does not include 0 degrees. So it's anything between 0 and 90, but not including 0 and 90. That's called an acute angle. As we sit up here, an angle that measures exactly 90 is a right angle. And that little symbol, that little thing, is a symbol for a right angle. An angle that measures between 90 and 180, that's called an obtuse angle. And then an angle that measures exactly 180 is called a straight angle because, well, it's a straight line. The lesser known one is an angle that measures between 180 and 360. That's called a reflex angle. So if this is my initial side and my terminal side's down here in, say, quadrant 3, then that angle right there is a reflex angle. If my initial side is here and then my terminal side is, say, down here in quadrant 4, that is what's called a reflex angle. Now, angles can be measured positive or negative. A positive angle, though positive angles, they're measured from the initial side, which is, we said, the positive x-axis, and they're measured in a counterclockwise direction. Okay, so it means that we're going to go up and around. Negative angles are measured from this initial side down in a clockwise manner. All right. So we already have the labelings of 0, 90, 180, 270. But if I'm going in a negative direction, if I'm going down, then this down here is negative 90 degrees. That's negative 180. That's negative 270. And then one trip around would be negative 360. So let's talk about sketching the following angles here. So a 30 degree angle, what does that look like? Well, a 30 degree angle is going to be in quadrant 1 because it's between 0 and 90. Right? Notice my initial side here is along that positive x-axis. My vertex is right here on the origin. And that. Now, I'm not going to get really technical about this and measure these out for you guys. We don't have to, you know, bust out a protractor or anything like that. But, you know, it's close. 45 degrees. Now, 45 degrees is halfway between 0 and 90. So that means my terminal side of my angle is going to be halfway through quadrant 1. Again, notice how I've got that red part accented, that's my vertex on the origin. My initial side is along that positive x-axis. All right, in which quadrant does 170 degrees fall into? Well, remember, it's 0, 90, 180, 270. So 170 degrees is right here in quadrant 2, right before that 180 degree mark. So there's my initial side. My terminal side's over here in quadrant 2. And that angle right there is my 170 degree angle. (225 degrees). Well, again, remember 0, 90, 180, 270. So it's 225 is between 180 and 270. So that's going to fall into quadrant 3. But where in quadrant 3? Well, it turns out that it's actually halfway in quadrant 3. It's halfway between 180 and 270. But notice my initial side, standard position of this angle. My terminal side's down here in quadrant 3. All right, so let's talk about sketching these negative angles. The negative just controls the direction. So now instead of going in that counterclockwise direction, now we're going to be going down in that clockwise direction. So negative 100 degrees. Well, remember, this is my 0. This is my starting or my initial side. This was negative 90. This is negative 180. So negative 100 is right here between negative 90 and negative 180. So with that terminal side here, down here in quadrant 3. Negative 359 degrees, that's almost one revolution. It's almost one trip around. So again, there's my initial side. And look, almost all the way around here. And that's going to put it in quadrant 1, and it's going to be like really super close to that initial side. Those initial and terminal sides are super duper close together. They're only like a degree apart. 462 degrees. I know that one's not negative, but I am making a point with this one. So where is that? Well, that one is bigger than 360 degrees. So here's what we have to do. So we start here at 0. One trip around is 360. And then I have to keep going. Well, if I keep going, I get 0, 90, 180, 270. If I keep adding 90, I get 360, 450, 540. So you can see that 462 is here between 450 and 540. So that terminal side here is going to be in quadrant 2. Now it turns out that 462 degrees, its initial and terminal sides look identical to 102 degrees. Now where did I get 102 degrees from? I'll grab a calculator real quick here and show you. If I take 462 and I subtract off that one revolution, I get 102 degrees. Okay? There's actually a name for this. These angles who share a terminal side are called coterminal angles. Coterminal angles differ by 360 degrees, or some multiple of 360 degrees. Okay? So we say 462 is coterminal to 102 because they differ by 360 degrees. It means that if you were to sketch 102 degrees, and if you were to go and sketch 462 degrees, you can't tell the difference. Right? There's just an extra revolution in there. Their initial and terminal sides are the same. So let's find a positive angle between 0 and 360, that's within 1 revolution, that is coterminal to 510 degrees. Well, seems kind of easy, right? All we got to do is just take out the extra revolution. So let's take 510 and let's just take out that extra 360 degrees. So we get 150. I want my answer to be within 1 revolution, between 0 and 360. So all I had to do is take out that 1 revolution. All right, no big deal. Okay, so I'm just going to do that one for this. 800 minus 360, oh, 440. That's not between 0 and 360. That's because there's another revolution in there. Okay, so let's take out another revolution. Ah, cool. Okay, now I got 80. So for this one, coterminal angles may contain extra revolutions. It doesn't have to just be one 360 degree revolution extra. It could have multiple revolutions, okay? So with that in mind, what is a positive angle between 0 and 360 that's coterminal to 1900? All right, so 1900 minus 360, oh, too big, minus 360, all right, minus 360. Okay, how do we know when to stop? I'm just going to keep going here. Well, I'm going to stop when I get an answer that's between 0 and 360, right there. And I eventually got that with 100. Now, what I did to shortcut this, if you don't want to just keep subtracting 360, you can take this 1900 and divide it by 360. When I did that, I get this decimal. That whole number right there, that whole number part of the quotient, that 5, tells you how many revolutions there's going to be extra in there. So then I took out those 5 groups of 360 by just multiplying them, because that's the same thing as just subtracting 365 times. So that's just a little shortcut if you wanted to use it. Okay, and then lastly, 510 degrees, negative 510 degrees. Now with this one, if I take negative 510 and I subtract 360, I'm just going to keep getting a bigger and bigger negative number. Well, when I say it differs by 360, in this case, because the angle is negative, I'm going to add 360 because that's going to be a revolution in the opposite direction. So that puts me at negative 150. Still not between 0 and 360. All right, well, let's add 360 again. All right, oops, didn't mean to do that. So we added 360, added 360 again, and I ended up at 210. That is between 0 and 360 degrees. So with these negative angles, we're going to add 360 degrees to it. If you keep subtracting, you're just going to keep getting a bigger and bigger negative number. Whereas if you add, so when I say that, it differs by 360 degrees, I mean that you're either going to have to add or subtract 360 degrees. So, all right, that concludes the in-class portion of section 7.1.